Thank you all for coming. So I'm very excited to be talking about something that I don't do research in, but that I'm very personally interested in, the prospects for sending humans into space. And in particular, I'm going to talk about the prospects for sending people to Mars. And actually, the real title of my talk is Please Send Me to Mars. So I'm going to try and give a good argument for why I, in particular, should be going to Mars, but why it's an interesting idea to go to Mars, what we might find there, what the challenges would be in sending people there, and what we can encounter along the way. So this is, so just to mention this, unless otherwise stated, every picture here is from NASA. They have an amazing array of space pictures and Mars pictures in particular. So this is the Mars Curiosity rover, Mars Science Lab, and it's been on Mars for almost 5 years now. And in fact, earlier this month marked the 20 years of continuous presence on Mars with NASA, either through rovers or orbiters or landers. NASA has had robots monitoring Mars for 20 years continuously. Started in 1997 with the Pathfinder rover, although there's been a lot of missions to Mars involving robots over the years. And Curiosity, I'll talk about quite a bit, is a sort of flagship rover out there on Mars. I have not been to Mars. I have, however, been to simulated Mars at VSEC. That's me on the simulated Mars surface, and I think I would fit in really well right next to the Curiosity rover there. Obviously, it needs some protective gear, but that's the idea. It's more or less to scale. The Curiosity rover is about this tall. So why Mars? There are some good reasons to check out Mars. It is right next door. It's a similar size to Earth. It's not so much smaller that you get, minimal gravity. The gravity on Mars is about 38% what you have on the Earth. So, you can walk around there. You won't accidentally leap into orbit, which is something that could happen if you go to comets. The mass of Mars is sort of in a similar range, and the size is about half. So it's not that alien. It's our neighbor in space. It's a neighbor in the sense that it's 225 million kilometers away. At the moment, it's actually a little bit farther. It depends on where things are in the orbit. It's close to its farthest point now, which is the farthest point is around 400 million kilometers. Right now, today, it's 396 million kilometers. But in the cosmic sense, it really is right next door. It's also not completely lethal immediately. Once you land on surface, if you have some kind of protective gear, you won't die just by landing, which is not something you can say about all the planets. And it's obviously undeniably beautiful in a sort of deserty way. There's been some just incredible pictures sent back by these rovers. This is a picture from Mars Curiosity of the hills of Mount Sharp, where it's been wandering around for the last several years. I look at these pictures and I think I could just go for a walk out there. These kinds of images really bring home that this is a world, and it's the kind of world you could really see yourself just wandering around on. It's so similar in so many ways to Earth. Just as a side note, we have another neighbor in the solar system, Venus. This is not recommended as a place to visit. Venus has a few challenges. It's got an atmosphere, has a sort of rocky surface. That's all good, but the atmosphere is extremely thick and extremely hot. The surface temperature is around 465 Celsius. It can melt lead. It's also extremely high pressure, 90 times that of Earth. It's a very dry surface. There are active surface volcanoes. There's a carbon dioxide atmosphere with sulfuric acid clouds. We have actually sent things to the surface of Venus. This is an image from the surface of Venus from the Venera 13 lander. It lasted for 127 minutes before it succumbed to the surface conditions on Venus. So that's not somewhere we should go. I mean, there is discussion about cloud cities. You could potentially have things floating in the atmosphere of Venus if you build it right, and there the conditions might be reasonable, but it's not a place you can walk around. But Mars is a place you could walk around. This is an image from orbit of part of the track of Mars Curiosity. If you can see, maybe not in the back, but there's this line that goes down here. This is the path of the Curiosity rover. That's about 5 kilometers of the path. And you can actually see, if you're close up enough to this picture, the lines of the two sides of the wheels. That's from a spacecraft called the Mars Reconnaissance Orbiter, an instrument called HiRISE, which has sent back some really amazing things. So far, Curiosity has traveled almost 17 kilometers across the surface of Mars, but it's not the longest trips. There's a rover called Opportunity that's been there for 13.5 years, much longer than its original mission, and it's gone about 45 kilometers at a very slow pace, but it's been traversing Mars. So we've got stuff out there, finding some really interesting things as robotic explorers. And some of the things that have found is that Mars may have been habitable in the past. It looks like Mars used to have liquid water running across the surface in streams. This is a picture of a sort of ancient Martian stream bed. Maybe a few billion years ago, there was water running across the surface there in a stream. And there's actually possibly liquid water on the surface of Mars today, occasionally. So this is an image of what's called these are recurring, they're called recurring slope lineae. These lines here are these sort of wet patches that show up on the sides of craters every once in a while in the Martian summers. And they seem to be some kind of briny liquid water that shows up once in a while. This is a series of images showing these things showing up. So downhill is sort of that way, and they're kind of seeping down the hill there. So although it's a very cold planet with a very thin atmosphere, there can occasionally be a little bit of liquid water on the surface, potentially. Although it's not pure water, it's sort of this briny stuff. Okay, so let's say we actually want to go to Mars. There are 3 steps to that process. One is that we need to escape Earth, we need to survive the journey, then we need to land on Mars. So it's a little illustration of one of the paths you can take to get there. All of these are difficult things to do in their own ways. So first, escaping the Earth, you need a really large rocket. There are a couple of reasons you need a large rocket. One is that you need to go quite fast. The escape velocity of Earth is something like 11 kilometers per second. And you need to escape the gravity of Earth to get out into space to then get to Mars. The other reason is you need to carry a lot of stuff. You need something that is powerful enough to lift a whole lot of mass, because you need to carry a lot of fuel, get to Mars, land on Mars, and then potentially come back. So these are some of the sort of future rockets that have been discussed as ways of getting things to Mars. This one is the SpaceX Falcon Heavy, which is currently being developed to take a robotic lander to Mars. This one probably won't be able to generate the necessary lift, but the next one is NASA's proposed launch system. This is called the Space Launch System. This one is for cargo. They have another one that's for potentially for a crew vehicle. And then the biggest one over here is a proposal by SpaceX called the Interplanetary Transport System, which is definitely farther in the future. But that's the one where they're talking about sending large numbers of people to Mars. This is just an illustration of what the NASA one might look like taking off if it is developed. This is the Orion capsule, which is proposed as the crew capsule to go on top of that rocket. So surviving the journey is another hard part of this attempt to get to Mars. I was looking at images of this Orion capsule to see how much space the people would have on the inside, because this journey to Mars would take something like 9 months each direction. And that would be a very small space to stay in for 9 months. There are proposals to have sort of inflatable living quarters that come off of these kinds of capsules, larger rooms to stay in. But the fact of being confined in a small space is one of the things that's difficult about going to another world. And Mars is very far away. It only took a few days to get to the moon. It will take many months to get to Mars, just because it's a heck of a lot farther. And so there are a lot of challenges. I was looking at some literature from NASA about the challenges of living in space, and they had this wonderful, cheerful graphic about all of the ways that space can seriously mess you up. And each of these icons is a representation of different ways that space can seriously mess you up. So one is lack of gravity. This is a bigger problem than you might realize. You end up with, if you have no gravity, you don't have, you're not exercising your muscles, you're not reinforcing your sort of bone strength. So people end up losing the minerals from the bones and muscle mass. It can mess with your kidneys. General disorientation can be a problem. The experiments on the International Space Station have shown that vision problems can occur. A lot of astronauts leave Earth with perfect eyesight and come back needing glasses. And this is something that's been seen in many cases for people who spend a long time outside of Earth's gravity. Well, they're not outside the Earth's gravity, they're orbiting, so they're in microgravity. But if you're going a 9-month journey, you're going to be in minimal gravity for quite a while. Another one that I only recently found out about, which is really upsetting, is that a lot of astronauts lose their fingernails. So it's something about the gloves you wear on a spacewalk that they can make your fingernails fall off. And there's even a story about, like, apparently some astronauts will just remove their fingernails ahead of time in order to deal with it. Yeah, lots of unpleasant things can happen to you just from being in space and in this weird environment. Another thing to worry about is just that it's a closed environment. So you have things you need to take care of in terms of bacteria and disease transfer, can cause allergy problems. And then just the stress of being in a confined space can be a problem in many cases. One of the biggest things to worry about when going to Mars is space radiation. So if you're on a long trip like that, then you're outside of the protective magnetic field of the Earth for quite a while. And the radiation from just cosmic rays in space and from high energy particles from the sun can cause a lot of problems if you don't have proper shielding. And so one of the big challenges is designing a long-distance spacecraft that can be sufficiently shielded from radiation so that you don't end up with all of the astronauts getting cancer and nerve damage and things like that. Then just the distance from Earth can be a problem. In this case, if you're going to Mars, you have a light travel time delay. At the moment, it would take 22 minutes to get a message between Earth and Mars. That timing varies as the orbits vary, but it's a while. So if something goes wrong, you can't get feedback immediately from the Earth about what to do about it. And you have to, you can't just like walk over to the doctor. You have to have all the expertise you need with you. And then the isolation and confinement is another thing that is a really big problem, because it's very hard to take a large living space on that kind of journey. And so people will be living in quite confined rooms for a very long time. And that can mess with people. There have been several isolation experiments carried out by NASA and ESA, other space agencies, where they put people in some kind of confined space for a long time, have them do simulated mission activities and just see what happens. So one of them was called the Mars 500 mission. This was by the European Space Agency, where they had a number of sort of capsule type rooms, and they put 6 men in these rooms for 520 days in a facility in Moscow. And this is what the inside of one of those capsules looks like. So they had like exercise facilities, they had various kinds of entertainment facilities, they had a little greenhouse. And as you can imagine, for an experiment like this, where you're putting 6 people together for over a year, there's a lot of testing, a lot of psychological compatibility and things like that. But it still caused a lot of problems. So one quote from a researcher who was looking into this said, only 2 of the men adapted well to the mission. Of the other 4, there was at least one major reason for concern, where we would ask, should we really send someone like this on a long mission? So most people have a lot of trouble living in a small space for a long time, even if you do very special screening and really try and make sure that everybody gets along and everybody's in the best possible mental state. This is going to be one of the biggest challenges for long-distance space travel, is just making sure that everybody is sort of okay with that mentally and emotionally. And that's something that NASA and ESA are doing a lot of work trying to figure out what the best kind of crew mix would be and how you can deal with these kinds of problems as they arise. But it's not all problems, it's not all bad things. There are some really positive things that come out of this. One of them is called the overview effect. So this is a video from the International Space Station looking down at the Earth over the course of part of an orbit. And one of the things that astronauts always say is that they get this, this feeling of a sort of global consciousness. Astronauts, as they get outside of the Earth and look at it from above, it can change their perspective on the world, on their place in it, and oftentimes bring about a sort of sense of peace. And this is something that maybe doesn't get accounted for when you put people in boxes in a facility in Moscow, but would be a much different situation if you were actually sending people to a real place outside of the Earth. But it's also just generally good for humanity in some ways to get this kind of perspective. One of the outcomes of the moon missions was pictures like this. The first time that we were able to see the entire Earth all at once from outside of it. This is a picture from Apollo 17. This is called the Blue Marble. And I always find this picture very affecting. It was the first time a human being was able to, the moon missions were the first time a human being was able to look at the entire Earth all at once and see everybody in the world in one frame, and see, the sort of fragileness and smallness of our planet. So, okay, so that's the surviving the journey part. Then the next step is you have to land on Mars. And this, again, is a very difficult part. There are a couple of reasons it's hard to land on Mars. And it's been shown that something like 2/3 of missions to the surface of Mars fail. There's a nickname for Mars, the Great Galactic Ghoul. It tends to eat spacecraft. And the reason that it's so hard to land on Mars is that it has just enough atmosphere to be a problem, but not enough to be helpful. What I mean by that is there's enough atmosphere so that when you're coming in, you need a heat shield. You need to deal with the fact that there's air there, unlike when you're going to the moon, where you can just kind of float down and use retro rockets once you get to the surface. When you're coming to land on Mars, you're going to have to do something to protect the spacecraft from that high-speed air. But then the air is not enough to slow you down so much that you can actually land softly on the surface. A parachute isn't sufficient. So, for example, this is from the Mars exploration rovers. Opportunity and Spirit landed like this, where they had first a heat shield thing, then they had these parachutes, and then they turned on these retro rockets to slow down even more, and then the final stage was this bouncy inflatable ball, where at some point the parachute lets go and the ball just bounces around the surface until it slows down enough and stops, and then the bubbles deflate, and the lander is able to open up and the rover can move off. That's something that worked well for the Mars exploration rovers, because those were only something like 500 kilograms of stuff. But then when we were sending the Curiosity rover, which is about a ton, this wasn't going to be sufficient. You can't bounce it around the surface anymore. So at that point, they needed this extremely complicated system where first they had a heat shield, then they had a parachute, and then they had the parachute lower down this thing with a crane. And at that point, it had retro rockets, and then it lowered down on wires, and then the lander came down and hit the surface, and then the sky crane, which was the thing with the rockets, shoots off so it doesn't land on the lander and goes away. This whole process, entry, descent, and landing, was known as 7 minutes of terror. There was a wonderful video put out about it before this mission landed, and it seemed to be an absolutely ridiculous way to put something on the surface of any planet, but it was necessary because when you have that big a mass and you're trying to get someplace like Mars, you need somehow to slow down enough so that things are not, completely smashed on the surface. If we want to land something heavier than the Curiosity rover, then you really need to have rockets that can land on the surface. You're not going to be able to do a whole lot with parachutes. And so the kind of thing you need is probably the sort of thing that SpaceX is developing, where you could land a rocket, a very heavy thing, vertically. And this is something that has not yet been achieved in a Martian environment. There's the vehicles that SpaceX is developing have been tested to some degree, but haven't yet successfully landed in that way. And at the moment, it's a little unclear exactly what NASA's plan for that is. But we'll definitely need something like that in order to land on the surface, and that's a very hard thing to do, as anybody who has been watching SpaceX developing this technology has seen. They don't always end up nicely standing intact like that at the end. Okay, so let's say that you manage to get to Mars. Then the next step is figuring out how to live there and survive on Mars. So there are a few basic needs for survival. If you want to be a human being living on a planet, you need oxygen, water, food, shelter, and you need to sleep. Unfortunately, Mars is really bad for all of these things. It does not have oxygen at any reasonable level. The atmosphere is 95% CO2. Otherwise, it's got nitrogen, argon, trace amounts of oxygen, but also the air is just really, really thin. The atmospheric pressure on the surface of Mars is around 0.6% of Earth's atmospheric pressure. There's very little air there. So that's one problem. Then water is another problem. Although there may be those little rivulets of briny water on the surface occasionally, it's generally just too cold and too low pressure for water to be liquid on the surface of Mars. This is a diagram, a phase diagram of water. These details are not so important, but this is pressure versus temperature. And in different pressure and temperature regions, water can be vapor, solid, liquid, whatever. And the conditions on Mars are kind of in this region here. So mostly so cold that water is solid, and then usually it'll jump right into vapor. It'll sublimate if it gets a little bit warmer. There are a couple of places on Mars in the bottoms of canyons where the pressure might be a little bit higher, and on certain very warm days, the temperature might be enough that you could just sneak into this liquid water region a little bit once in a while. But for the most part, water on Mars is either vapor or solid, which is not very helpful. The next item is food. Obviously, there's nothing growing there at the moment as far as we can tell, but it's also true that the soil is probably completely toxic. It's going to be sterilized by radiation because there's not enough atmosphere to protect the surface from cosmic rays and the solar wind and everything. But it's also true that the chemicals in the soil include something called perchlorate, which is something that tends to destroy bacteria. And if you connect perchlorates with UV radiation, which is stuff that also would be getting to the surface of Mars, at the moment, it seems to be the case that the first at least meter or so of soil on Mars is probably completely sterilized by those two things. There's a mission called ExoMars, which is a European Space Agency and Russian collaboration, which is going to be sending a lander to dig down 2 meters into the Martian soil to look for the possibility of microbial life deep down there. But on the very surface, it's probably going to be very hard, which is going to make it difficult to grow food. Shelter is another thing. Because of this radiation environment, it's going to be very hard to be in to sort of build a kind of shelter that would be suitable and safe. But there's also toxic dust particles, and this is something that isn't discussed very often, but the surface of Mars is covered in very, very thin dust. And we see the results of that with spacecraft. So this is one of this is the Spirit lander, one of the Mars exploration rovers. And these two images are, I think, 2 years apart. And you can see what's happened with the dust. It's settled on top of those solar panels, which is bad for solar panels, but really bad for people, because that kind of dust is so fine that it could lodge itself in your lungs. It could become toxic, make it very hard to breathe. And if you're on the surface of Mars and you're walking around and then you go inside, whatever kind of shelter you have, you're not going to be able to get rid of that dust necessarily. So we're going to have to figure out ways to filter the air in a way that current technology is going to have a lot of trouble with. So the dust is another thing to worry about. Just as a side note about the dust, these solar panels should have the dust settling on the solar panels should have limited the lifetime of these rovers much more than it did. Fortunately, though, Mars also has dust devils, and it's thought that sometimes these dust devils can nicely sort of wipe that dust right off of the solar panels. This is a picture from orbit of a dust devil on Mars, a little whirlpool of dust reaching into the sky. And you can actually see movies of these dust devils moving across the surface of Mars. This is a movie taken from the Spirit rover of this sort of little miniature tornadoes of dust moving around on the surface, and sometimes those can go over the rovers, clean off those solar panels, and make them able to bring in power again. So that's kind of neat. They're also really cool because they leave tracks. So this is a picture from HiRISE again, where you can see tracks along the sand, and these are dust devil tracks. So as these dust devils move across the surface of Mars, they leave these little lines all over the place, which I just think is really neat. Anyway, the dust devils, by the way, the sandstorms and dust devils and things are not dangerous for people in the sense that they're not going to like destroy habitats or blow over spaceships or anything, because the air is so thin that if you saw the movie The Martian, there's this massive dust storm that caused a lot of problems. That's probably not going to happen, but the dust itself can be a really big problem. So finally, sleep. You would think that you just sleep like you normally do, but it's actually kind of difficult because the day on Mars is a little bit longer than 24 hours. It's 24 hours, 39 minutes, 35 seconds, something like that. So it's kind of like perpetual jet lag if you're on Mars. So this has been seen because there are scientists working on these rovers who have to live on Mars time for a little while when the rovers land, where they have to sync up with the day of Mars so that they're awake when the rover is getting sunlight and able to operate in the Martian daytime. And that can cause really big problems for a person. It's kind of like moving 2 time zones every 3 days. And that kind of jet lag is not healthy. So for example, if you're on Sol 1 and you wake up at 6 a.m., then on Sol 7 you're waking up at what feels to you like 10 a.m., and then on Sol 14 you're waking up in the middle of the afternoon, and then 21 you're waking up in the early evening. On the 28th Sol, you're waking up just before midnight, and then on the 35th Sol, you're waking up early in the morning again. And that kind of cycling would be really hard on a person, depending on sort of how they deal with jet lag and sleep. So that's something that also would need to be considered for if you're going to actually live on the surface. Fortunately, there are ways to deal with all of these issues. With oxygen, there's an instrument being developed right now for NASA's Mars 2020 lander called MOXIE, which can take carbon dioxide and create oxygen out of it. And this particular model is just going to sort of vent the oxygen into the air. But in the future, instruments like this should be able to create oxygen that's breathable on the surface of Mars, just using these kinds of reactions. So that's one way to get around the oxygen problem, although you still need to be sheltered and collect that and pressurize it. For the water, it's actually the case that there's a lot of water on Mars in the soil itself. So I mentioned that water can only be frozen or gas in most places on Mars. The water in the atmosphere is not very useful because the atmosphere is so thin, but the water in the soil could actually be mined. So there's this great graphic from a document called Mining Water on Mars, where NASA was looking at how you could get water out of the surface. And the sort of middle latitudes are pretty dry, but as you go farther out, you get continuous ice. So the soil is just full of water ice on the higher latitudes on Mars, and we've actually seen this. So this little spot up here where it says PHX, that's the landing site of the Phoenix lander. And that lander was there partially to look for ice. And it had this little digging tool, and it dug into the surface, and you can see the white there of subsurface ice. And the cool thing about this picture here is, so it dug into the surface, and over here you can see these 3 little, they look like rocks, and in this picture they're gone. And what that is it's a little bit of ice that was sort of knocked out of the surface, pulled out, and then it sublimated a little while later. But it showed that there is ice very, very close to the surface in these sort of polar regions. So one of the ways you could get water on Mars is to go and find the ice, dig it up, and then melt it and use it for whatever you need. And there's quite a lot of it, so that should be manageable. In terms of food, as I mentioned, the soil is completely toxic, but that doesn't mean it doesn't have some chemicals that are really useful. There was a great graphic from the NASA Journey to Mars sort of plan, where they're talking about all of the different nutrients that plants need are detected in Martian soil. So the Martian soil does have the kinds of chemicals that you would need to grow plants, as long as you can get those perchlorate chemicals out of there. So you'd first need to somehow separate the toxic chemicals from the soil, but the soil itself, the chemicals that you need, the sort of essential elements are all there. So you could bring along your own stuff, somehow try and separate the toxic stuff out of the soil, and then you could in principle use that to grow things. There's been some really great concepts for shelters on Mars, and I won't talk about all of them. The most obvious thing is to just go underground, because you do need quite a lot of shelter from the radiation. So if you could find a cave, or if you could dig underground and have some kind of underground layer, then that's the easiest thing to do. But there have been some cool ideas for alternatives to that, and one of my favorites is this one, which is an igloo concept. So it turns out that water is pretty good at shielding from radiation, and if you can make shelters out of water ice, then you could solve the problem of the radiation shielding and also have some natural light and not have to live underground in caves all the time necessarily. So these are the kinds of things that are being developed for potentially living on Mars, and I think it would be very cool to go to Mars and live in igloos and have that light coming in and have that shielding, and it just seems very sort of cool and futuristic in a sort of fundamental way. And then sleep. For the sleep, the main thing I think you would need to do in this case, and this is not something that that NASA's talked about, but I think is a good idea, is there are some people who just have different cycles. Everybody has a different sleep cycle. Some people like to wake up early, some people like to wake up late, and some people who like to wake up late have what is called delayed sleep phase disorder. And basically, those people are just on a longer than 24-hour cycle. In general, if you take the average human and you put them in a place where they don't have light cues, then they'll be on a cycle that's a little bit longer than 24 hours, something like 24.2 hours. But some people can have cycles that are even longer, 25 hours or something like that. So if you can find people who naturally wake up a little later every day, then you can send them to Mars. They'll be perfectly on time, and everything will be great. I bring this up partially because this is me, but I think it's a good idea. I think that I would do very well with having a slightly longer day. So that brings me to my point about sending me. I think this is a good plan. So some qualifications for Mars. I have very good eyesight. This is important because my eyes might get messed up by the long space flight, but they're going to start from a good point. And also, when you're on Mars, when you're in the lower gravity, you probably can't walk around in the normal way. There's a little bit of jumping. And I am a champion high jumper, as it turns out. So that would be fine. I'm also quite fond of desert locations. I've been up mountains that are so high that I'm pretty sure there was no air there anyway. So I'd be great in this sort of very thin atmosphere, very deserty place. I've also spent time in the physics mines. This is a picture of me in the Stahl Underground Physics Lab, or the sort of proto-underground physics lab. There's an experiment that's being developed here at Melbourne University with some other collaborators where we're going to make a dark matter detector in a gold mine in Victoria. I've been down there, but I've also spent time in a zinc mine in Japan looking for neutrinos. Anyway, living underground is fine if that's what needs to happen. I've also applied for NASA, and I've made the highly qualified list. This is the first cut when you apply to be an astronaut. The astronaut application program is not what you might expect. It's an online application. It's a government job, so there's a website called USA Jobs. And you go on that website and you upload your resume and you fill in a lot of forms. And then there are a couple of extra forms that are specific to the astronaut program, but for the most part, it's very much like applying for a government job. And so I applied for that in 2012. And after sending in all my forms, I got this letter. And it doesn't sound that exciting in what they actually say on the letter. But what this letter is telling me is that I've been chosen for the highly qualified list, which to that point was taking it from 6,000 applicants to about 400. And then once you get on the highly qualified list, then you send in your medical forms and your reference letters, and then they decide if they're going to interview you in person in Houston. Unfortunately, I didn't get to that list, but I did. I'm highly qualified, so just putting that out there. And then finally, I have a very strong family history in space exploration. This is my grandfather. He passed away a few years ago. His name was Captain Willard Samuel Houston, and he was a Navy meteorologist. And he worked for the Navy for a number of years, and in the late 1960s, he was called upon to work for the Apollo 11 program. The Apollo 11 program, as you know, was the first trip to the moon with humans to land on the moon. And my grandfather's job was to look at the weather on Earth and make sure that when the lander was coming back to Earth, it would land in a nice place. So, you know, he had his the usual weather charts and everything, and he was checking on the weather to make sure that the place they wanted to put the capsule for splashdown was going to be okay. And it turned out that he, before he started working with NASA, had been part of a secret spy satellite program. Now, he wasn't a spy. He wasn't interested in spying on the Russians. He was using the spy satellites to look at weather patterns. And by the time he was working for Apollo, he wasn't involved in that spy satellite program anymore, but he still had access to that data. And he knew that there was going to be a satellite pass over the place where the splashdown was going to occur. So a couple of days before the splashdown, he went over to a colleague of his, Hank Brandley, and just asked to look at this secret spy satellite data. And so they looked at the data, and they saw something concerning, which was screaming eagle thunderstorms. Now, these are something that did not show up in the unclassified data, but that were showing up in the satellite data, the much higher quality data that these guys had access to. The problem was Hank Brandley wasn't allowed to talk to anybody because he was just connected to this spy satellite program. And my grandfather had high security clearance, but NASA did not. And so he could not tell NASA about this thunderstorm. He couldn't tell NASA that this satellite existed. It was completely secret, because if he'd done that, then maybe the Russians would have found out that we were spying on them. Major problem, Cold War. So my grandfather had to somehow communicate to NASA that these storms were going to be a problem, and the landing site would need to be moved. So my grandfather went over to the NASA command people and said, look, you have to move the landing. I cannot tell you why. I cannot show you any data, but you have to move the landing. And you know, they looked at my grandfather and they're like, what are you telling us? And he said, look, it's just really important. You have to do this. I can't tell you anything more. And so they said, okay, we trust you. We think you know what you're doing. We're going to move the landing, but this is a really big deal. It's only 72 hours until splashdown. So we're going to send airplanes to the original site too, and if you're wrong, your career is over. And so he said, okay, he's going to do it. So the splashdown was rerouted. They sent the commands up to the command module. They had the astronauts change the landing site. And the capsule came down in cloudy but reasonable weather. And the thunderstorms that would have been so bad that they could have ripped those parachutes right off the capsule were somewhere else. In fact, those thunderstorms were where the plane went at the original landing site. So if my grandfather had not been able to convince NASA to move that landing, then this is not the picture you would have seen. The astronauts would have come back from the moon, had the parachutes ripped off the capsule, and died on impact with the ocean. Fortunately, that didn't happen. My grandfather was able to convince them. The lander came down, the astronauts were recovered, the capsule was recovered, everything was great. So I like that story, but it kind of freaks me out every time I think about it, because I just think how the space program would have changed completely had my grandfather not had that access, had he not been able to convince the team to move the landing site. This, by the way, is a story that was classified until the 80s. And so that's why you probably haven't heard about it, because it was kept secret for a very long time, because those spy satellites, even after this all occurred, had to be kept a secret. And so my grandfather never got sort of public acknowledgement of that. He did get a medal, but it was kept quiet for a very long time. So anyway, so that's why I should be the one to go. I have the connection to my family. My granddad saved Apollo 11. I'm a good jumper. I think these are all good reasons. Okay, so let's say that we do get to Mars. Let's say we go there. We send me, everything's awesome. what's next beyond that? So there are a number of suggestions for ways to build sort of, big habitats on Mars. Maybe someday that'll happen. There's a lot of discussion about Mars being a kind of backup Earth, and I don't think that's a good way to think of it. And I'll talk about why not in a minute. But we're probably never going to send a large number of people. Elon Musk thinks we will. He's got this idea for this interplanetary transport system. Those are humans, to give you some scale there. This is his idea of landing on Europa. So maybe at some point, very, very large rockets will go and take small numbers of people. But even a rocket like that is only suggested to carry something like 100 people. And I think it's very unlikely that we will ever have the kind of funding necessary to send really large numbers of people to Mars, at least in the near term. Another thing that people talk about sometimes is terraforming, the idea of taking Mars and adding a lot of atmosphere to the planet through throwing comets at it or something like that, trying to heat it up with nuclear blasts, all sorts of ideas where you might be able to, over the course of a very, very long time, change the atmosphere from being extremely thin and cold to something people could live in. There's been a lot of research on this. This is part of a discussion of a sort of 1,000-year plan for terraforming Mars, where you start to create an atmosphere by releasing carbon dioxide from the ice caps and making the atmosphere thicker, and then putting in plants. And after 600 years, maybe you could have flowering plants. And then after 900 years, you could have sort of forest growing. And then by 1,000 years, you could have people walking around with just scuba gear and not entire sort of environment suits. But one of the things you should notice about even this plan, which is 1,000 years in the future, even this plan doesn't permanently change Mars. Mars can't hold an atmosphere. It doesn't have a global magnetic field. The lack of a global magnetic field on Mars is a problem for a number of reasons, one of them being the lack of radiation protection, but another being that it's just very hard for the atmosphere to stick to the planet if it's being bombarded by solar wind all the time. And there's been some research suggesting that, the thick atmosphere that used to be on Mars that was keeping it warm enough for liquid water to be on the surface was stripped off by solar wind when the magnetic field of Mars failed. So at the beginning of Mars's life, it probably did have a global magnetic field. At some point, that stopped. We're not really sure why. It could have been some kind of impact. It could have been the planet cooling so much that it no longer had a molten core. But whatever it is, it made it so that there is now no global magnetic field. And any atmosphere, even that we are able to produce, is not going to be able to stick around because the bombardment by the solar wind is always going to be pulling it away. So, Mars is a very beautiful place. This is a sunset on Mars. Sunsets on Mars are blue rather than pink because of the size of the dust particles and how the light is scattering. Mars is a beautiful place, and I think we should go there, and I think we should visit. I don't think we should think of it as a place that will save us from global calamity. There are a number of reasons for that. One is that we can't really live there over long terms without constant sort of life support systems. Another is that we're never going to be able to transport a large fraction of the human population, and so the people who are able to go to Mars is always going to be a small number of people, probably very rich people. And Earth is just so nicely built for us that we should probably work on preserving it. This is another picture from one of the rovers. This is from Mars Curiosity. The sunset was also Mars Curiosity. And in this picture, you might be able to see that sort of bright star there, which is not a star. That's the Earth. That is the pale blue dot of our planet. And I think it would be amazing if someday we were able to go to Mars, stand on the surface, stand there in Gale Crater next to Mars Curiosity, and look back at ourselves, and look back at that pale blue dot, which, in the words of Carl Sagan, that's home, that's us. I'm just going to say a few of the words from the famous Carl Sagan blue dot speech, where he was talking about the pale blue dot of an image of Earth from the Voyager spacecraft. But I think it applies just as well to this one, which is that it has been said that astronomy is a humbling and character-building experience. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known. Thank you.
Thanks very much, Katie, for a really beautiful summary of the issues around going to Mars, and what I think is a very coherent argument for why Katie should be. So, I think we've got time for a few questions. Got some? Yes. Yes.
Well, after Mars, what do you think will be the next, I should say, least inhospitable place in the solar system you might want to attempt to inhabit?
Okay, so the question was, after Mars, what's the least inhospitable place to go in the solar system? So I actually think the cloud cities in Venus is kind of a cool idea. If there's a way to build a sort of floating environment over Venus, I think that would be kind of neat, because the conditions, the atmospheric conditions there would be kind of reasonable if you're high enough up in the atmosphere. But some of the moons of Jupiter could be kind of neat. So like Europa, as Elon Musk was suggesting, would be a very cool place to go and visit. Europa, like some of the other moons of the gas giants, might have an undersurface ocean. So there's a possibility for life under the surface of some of these icy moons, and it would be really neat to go there and check it out. There is the problem of potential contamination, because if we go there and we bring our microbes and they mess with whatever life is there, that's a problem. It's a whole issue of planetary protection. But I think that would be neat. And there are places actually on Mercury that are not horribly cold horribly hot if you can keep moving. So the night side of Mercury is not all that bad necessarily. So you could potentially, people have talked about in science fiction, I don't know, if anybody actually thinks about doing this, but you could create sort of a global railroad and just kind of keep moving along, because the day is quite long, and so it takes, you can spend quite a while doing that. But I think in terms of long-term habitations, Mars is probably our best bet. You can build a moon colony, but I think Mars is much more interesting.
Another question?
Okay, whilst we're having this question, there's a lot of kids here tonight, which is terrific. If any of you have got a question, get it ready. Okay.
There are some people, a lot of people who believe that the Big Bang never happened, that planets do not exist, and that we never been to the moon because we can't get out to the bananas belt. So how are we going to get to Mars? But this stuff is too hard for me to digest. My question really is, on our planet is 25% water, Earth, and 75% water, correct? Now I would like to know, how is it possible that all this body of water, which is 75% water, does not fall off when the Earth spins? How is that possible?
So the question is, how does the water on Earth stay on Earth? And the answer is gravity. The force, the fact that the Earth is spinning does, to some small degree, change the amount of pull that you feel to the Earth, but not a very large degree. So the gravity is by far the dominant force in keeping everything onto the surface. The spinning is not so rapid that things can actually fall apart. And
Tell me, how fast is the Earth spinning?
It goes around once per day.
You mentioned that only the rich possibly
Wouldn't it be wise to send them there quicker?
So the question is, shouldn't we get rid of the rich and send them to Mars so that they don't cause problems down here anymore? I mean, I think that very realistically, the people who are able to afford tourist trips to Mars will probably likely be the most wealthy. However, that doesn't necessarily mean that they won't still have business interests on Earth. So I'm not sure that it'll really, you know, it's a 22-minute time delay, but they could still, you know, do internet banking. I'm not sure that'll be a solution, but we can try.
Yes, gentleman with the hand up.
Yep. Oh, thank you. You can jump pretty well now. That's great. So I'm thinking 0.38 G is not zero, but is there any real long-term studies or extrapolations to say how long could you really survive well on Mars, that sort of low G environment? In other words, you've got to hurry back to Earth, otherwise you're going to get all these problems and finish up the big graves on Mars, you know, pretty quick.
So the question is, you know, although it's not 0 G on Mars, it's a low gravity. Is that what kind of problems could that cause to the body? Some of the problems are going to be really well mitigated by the fact that there is gravity and you can wear heavy spacesuits. So the problem of, for instance, bone and muscle decay is probably not going to be anywhere near as big a deal, because if you're out on the surface, you're going to be wearing a heavy spacesuit anyway, and that will give you the kind of resistance that you probably need to keep healthy there. I don't know if you're going to have the problems with eyesight and things like that. I think those are the kind of studies that still need to be done to know over the long term what the effects will be. But I imagine that the first few trips to Mars will probably be very, very short in duration, and they can do some of these studies and then eventually stretch it out if people are still surviving. I think that it's going to be unlikely for people to be able to go to Mars and come back and be just as healthy as they were when they left. Part of that is the long duration space flight, which even just getting there, that's 9 months in space, which is a very, very long time. Most astronauts don't spend that long on the space station. So that's going to be difficult, and then the radiation environment is going to be very bad no matter what happens. So it's very likely that people will have to sacrifice some health in order to go. I think there are plenty of people who are willing to do that, but it's probably not the sort of thing where you're going to leave a very healthy person and come back a very healthy person, at least in the short term.
Okay, I think we're out of time. Before I thank Katie again, I'd just like to thank you all again for coming to tonight's lecture, and just to note that next Friday night we'll have the next in our series, which will be Associate Professor Michaela Trenti will be speaking about cube satellites and their